All right, so how do we graph a rational function? So I'm going to walk through these steps here and to help y'all kind of sketch a rational function. We'll check it with our calculator. So first we got to determine whether the graph has symmetry. So to find if it has symmetry, I'm going to calculate f of negative x. So basically what that means is anytime I see x, I'm going to plug in negative x in place. So 3 times negative x minus 3. And I'm going to see if I can find a pattern here. Negative x minus 2. 3 times negative x is negative 3x minus 3. And there's just negative x minus 2. Now I'm going to see one of two things can happen here. Is this equivalent to the original function? No. So it's not, doesn't have y-axis symmetry. And could I factor out a negative and get the same thing? Well, if I factor out a negative, or basically, let me simplify this for you. Are the signs the same? Are the signs different? So if everything's the same, it's got y-axis symmetry. If all the signs are different, then it has origin symmetry. You notice that some of the signs are the same, but some are different. So this one's neither. This one doesn't have any symmetry. So that didn't really help us out any. Okay. Next, we're going to find the y-intercept. So to find the y-intercept, you make x equals 0. Okay, so we're going to make x equals 0. So I'm going to find f of 0. So 3 times 0 minus 3 divided by 0 minus 2. So I'm just going to plug in 0 for x. 3 times 0 is 0. 0 minus 3 is negative 3. 0 minus 2 is negative 2. Negative 3 divided by negative 2 is positive 3 halves. So my y-intercept, okay, is 0, 3 halves. Okay, now I'm going to plot that point. 0 on the x, 3 halves on the y. Okay, so there's my y-intercept. Okay, now the x-intercept, what we do is we set the top equal to 0. So find the x-intercepts, make the top equal 0. So the top equals 0. And by the way, the first thing I should be doing when I do this is I should be trying to simplify this or factor this, and I didn't do that. Okay, so I apologize. So make the top equal 0. So I'm going to make 3x minus 3 equals 0. So I'm going to add 3, 3x equals 3, divide by 3, divide by 3, x equals 1. So 1, 0 is my x-intercept. So my x-intercept's 1, 0. So I'm going to plot that point. Okay, that's step 3. Now, to find the vertical asymptotes, I'm going to kind of start grouping this up a little bit. It's getting a little messy. To find the vertical asymptotes, you make the bottom equal 0. Make the bottom equal 0. Okay. So x minus 2 equals 0. Add 2, x equals 2. So that's my vertical asymptote. Okay, now, how do I graph this? Okay, we haven't graphed an asymptote before. So what I'm going to do is I'm going to go to the line x equals 2. Okay, I'm going to go to the line x equals 2. I'm going to go to the point x equals 2, should say. Okay. And then I'm going to do a vertical line because x equals 2, that's what x equals 2 looks like. Okay. All right. Next, I need to find the horizontal asymptote. And so for the horizontal asymptote, we ask ourselves, which one has a higher power, the top or the bottom, or is it a tie? Well, look at this. You see it's a tie. It's high because the highest power of the top is 1, the highest power of the bottom is 1, so it's a tie. So it's going to be y equals the leading coefficient of the top, which is 3, divided by the leading coefficient of the bottom, which is 1. It's 3, so it's y equals 3. It's my horizontal asymptote. Now, what is y equals? Remember, x equals the vertical line. Y equals is a horizontal line. So it's a horizontal line. Now, what are asymptotes? Asymptotes are imaginary boundaries that your graph will never cross or touch. Okay? All right. Plot at least one point between each x-intercept and vertical asymptote. Okay, and then use information to graph the function between vertical asymptotes. All right. So now what I've got here, what I know is that my graph, remember a rational function, your traditional rational function does, it's kind of curved. It kind of it approaches the asymptotes, but doesn't touch it. So I know I'm going to have a curve in this region because I know my x-intercept's 1 and my y-intercept's 3/2. So what I'm going to do is, it's going to be a little bit of a white trash sketch. I'm going to sketch a curve in this region. And what on this side is going to be approaching that vertical asymptote, but not touching it. And over here, we're going to approach the horizontal one, but not touch it, okay? Now, where's your other curve going to be? Remember, a rational, you got two curves, or for most rational functions have at least, two distinct curves. Well, if it's just a rational with a power of 1, the second one will be diagonal, okay? If it's a squared, then it's going to have symmetry along the asymptote. So it's going to be symmetric to the vertical asymptote, okay? And so this is my graph. I was going to show you real quick. I can go to my calculator. I like being able to use your calculator to kind of check your answers. So you type that in there and then you press graph and you look and you see, I mean, obviously they were not going to graph. You can't see the asymptotes in the calculator, but at the very least you can kind of get an idea of making sure your curves are in the right spot, and mine are. So